Good morning, everyone. Myself, Shanmugapriyan. In this topic, we are going to see about humidity sensor. Before saying humidity sensor, let's see about what is humidity. Humidity is nothing but water vapor in atmosphere. We don't see it's happening, but almost all normal atmospheric conditions, some volume of mass of water vapor evaporates and condenses into a constant cycle. When water evaporates, it rises and disperses into the surrounding air as a gaseous water vapor. Humidity is a presence of water vapor in atmosphere. More water evaporates in the given area, the more water vapor rises into the air, and higher the humidity level in that area. Hot places tend to have more humidity because heat causes water to evaporate faster. It might sound like water evaporation is a bad thing. Liquid water is useful, plus essential is for all life. Water vapor doesn't like it's useful for much of the other than you making you uncomfortable. Believe me, believe me or not, water evaporation and humidity serve a critical function in our day-to-day life. When liquid water evaporates into gaseous water vapor, it has completed one third of the all water cycles. The water cycle is nature's way of distributing water to things that we need. If water didn't evaporate, we couldn't have clouds, and it would never rain. When water vapor rises, water molecules in the vapor combine with each other with other particles like dust, salt, and smoke. Eventually, these molecules latch together until they are big enough to visible as clouds. The higher the water vapor rises, the thinner the air around. It becomes less air. It means there is no gravity to press it down. Then less pressure. This less pressure makes the air molecules will be not pressed tightly, which lowers the air temperature. As it lowers the air temperature, the clouds condenses back into liquid form and water droplets are produced. For let me show you as a picture like this is the pond with water. The sun eats the water and it evaporates into water droplets. These water droplets will merge and mix components like salt, dust, and etc. and form into clouds. When these clouds condenses into liquid form, this liquid form will flow as water, that is raindrops. We all know this procedure. Let's talk about humidity. Now, let's talk about dew point. What is dew point? Condensation only occurs when there is enough water vapor in the air for molecules inside the vapor to condense into water droplets. The only way that happens if the water vapor condenses faster than it evaporates. The dew point is the temperature of air must be for water to condense and evaporate at the same time. If the air temperature matches the dew point, the air is saturated and it cannot be condensed firmly. If the air temperature increases and the water evaporates faster and condensation doesn't form. In this picture, you can see low dew point where there is no room for air to make more water vapor molecules. But in high dew point, The water molecules will be higher because there is. Let's see more about dew point. Dew point is a given body of temperature to which it's cooled to become saturated with water vapor. The temperature depends upon the pressure of the water vapor. When the air is cooled below the dew point, its moisture capacity is reduced and almost airborne water vapor will condense to liquid form, known as dew. When this occurs through the contact with a colder surface, dew point will be form of surface. The dew point is affected by air's humidity. The more moisture in the air contains, the higher dew point. When the temperature below the freezing point of the water, the dew point is called as frost point, where deposition occurs rather than condensation. In liquids, the analog of dew point is the cloud point. In next, in next slide, we will see about types of humidity. There are two types of humidity that are absolute humidity and relative humidity. Let's see about absolute humidity. Absolute humidity is nothing but the actual mass of water vapor present in the volume of air, typically expressed in grams of water vapor per cubic meter, that is, grams per meter cube. It represents the total amount of water vapor present in air as temperature. This measurement is crucial in applications where exact amount of water vapor in the air needs to be known. As an industrial process, agriculture, and certain scientific experiments. Now, for example, let's consider like let's take the water vapors which is equal to 30 grams, and which is present in a volume of air with a temperature of middle like 80 seconds. 80 seconds. The absolute humidity is expressed in mathematical terms like is equal to m H2O by delta V net, which means the value of absolute humidity differs from air temperature and pressure if the volume is not fixed. It is also affected by water's distribution on Earth and seasonal changes. As it is measures the absolute moisture in the air, it relatively remains constant. Now let's see about relative humidity. Relative humidity. Relative humidity is the ratio of absolute humidity at a given time to highest possible humidity, which depends upon the current air temperature. It measures water vapor relative to temperature of the air. It is represented in percentage. Then higher the percentage of relative humidity means that air water mixtures is highly uh, humidous. The relative humidity is affected by temperature and geographical location of the particular region. When the quantity of the water vapor changes the relative humidity, then the formula is given by Let's write. To relative is equal to. It's nothing but relative humidity, which is equal to absolute vapor density by saturation vapor density into 100. It provides a measure of to how close the air is to be saturation, with under percentage indicating the air is fully saturated with moisture. The relative humidity is widely used in weather forecasting and comfort assessments. High relative humidity can make the air feel warmer because the body cooling mechanism are less effective when the air is already saturated with moisture. Now, in this slide, you're seeing right the container is filled with water vapor and some amount of air. The total amount of water vapor is the absolute humidity, which is 50 percentage, and the water vapor plus the air, that is the absolute humidity, the density, and the remaining saturation water vapor is the total of relative humidity, which is 67 percentage. Now let's see up in the next slide. There is a famous quote by Nick Boston, like which says like mission intelligence is the last invention that humanity will ever need to make. In this, we infer that the mission, the artificial intelligence, is the best invention that humanity is ever made. By this, in this slide, we are going to see about how a humidity sensor work. What is a humidity sensor? A humidity sensor is an electronic device that measures the humidity to environment and converts its findings into a corresponding electrical signal. Humidity sensors are widely used in size and functionality. Some humidity sensors can be found in Android devices like smartphones, medical devices, and etc. Humidity sensors are somewhat it's an integrated and need an it's an integrated system with with electrodes and polymeric material. Um, some other humidity sensors are integrated into larger embedded systems such as air quality monitoring systems, which are used in the cold rooms, HVACs, and etc. The the commonly used industrial usage is where like metrology, medical, automobile, HVAC, like I said about, and manufacturing industries. Now let's divide the sensors into two groups. That are what we learned, uh, how to calculate the humidity, like relative humidity and absolute humidity. This relative humidity and absolute humidity can be also be sensors like a relative humidity sensor and absolute humidity sensor, which are comparing the readings and giving to given temperature to maximum amount of humidity in the air at the same temperature. The relative humidity sensor therefore sorry must therefore determine the relative humidity in the air atmosphere, whereas absolute humidity sensor must measure the uh, contrast and the saturation point in the air temperature. The relative humidity sensor consists of two common things like capacitive and resistive. Capacitive sensors use two electrodes to monitor the capacitance, that is the ability to store an electric charge of a thin metal strip placed between them. The metal capacitance increases or decreases at a rate that is directly proportional to change of humidity in the sensor's environment. In this slide, we can see about this sensor is uh, a it's a capacitive sensor where there are two electrodes, uh, which is a porous metallic material, and in between there is a polymer membrane. When the moisture is absorbed by the polymeric material, there will be some electric charge between these two electrodes, which will give an electrical signal to the display unit, where we can see what is the humidity of the temperature. The difference in charge generated by an increase in humidity is then amplified and sent to embedded computer for processing. The resistive humidity sensor operates in a different principle. These sensors utilize a small polymer comb that increases and decreases in size as the humidity charges, which directly affects the system ability to store charge. The we can see about how resistive sensor works. This in this slide we can see about the resistive humidity sensor. You can see uh, the outer material is the insulated substract. The curved like things, the like it's like an signal antenna in a Bluetooth module. We can see it's similar to that, but uh, it's the gap width and gap width between the electrodes, and the connecting pads are connected in here, as we see. And this is a porous sensing layer where the moisture has been absorbed through this, and we will measure the relative humidity through this. Um, there are other sensors like thermal humidity sensors, which are used to measure absolute humidity. Unlike the relative humidity sensors, thermal humidity sensors utilize two probes. One measures the dry nitrogen, and one measures the air of its surrounding environment. When the humidity is collected to the extended probe, the difference in the thermal conductivity is perceived by the sensor, and it's been calculated. This is all about the types of sensors in humidity sensors. Now let's see about the working principle of humidity sensor. In this image, we can see the working principle, like The first image, it explains about the there is three layers, where first layer is the protective film, the second layer is humidity sensitive film, and third layer is the ceramic substrate. The comb like structure is present between the humidity sensitive film and the ceramic substrate. You can see a wire system, like for example they're using an AGPD integrate interdigital electrodes, which will detect the moisture content, and it's been delivered to the central processing unit for calculation. Uh, let's see about one by one about the working principle of the humidity sensor. First, we can see about the capacitive humidity sensor. This device operates in a principle of electrical capacitance of a material which charges with it with humidity. Inside the sensor, there is a moisture absorbing the dielectric material. As this material absorbs water vapor from the surrounding air, the capacitance of the sensor changes. The sensor then translates the capacitance changed into humidity reading. The capacitive humidity sensor are widely used to their accuracy, reliability, and responsiveness to the changes in humidity. For example, let's see about the capacitive sensor. For example, let's take two dielectric medium. These are the two dielectric material. When there are moisture around these plates, when the plates these plates are produced with an electric charge, like now when the moisture contents enters between these two plates, there will be some change in charge, and this charge is used to calculate the humidity in the monitor, which is kept for measuring it. This is how the capacitive humidity sensor looks like. Now let's see about the next type, that is resistive humidity sensor, which employs hydroscopic material with the electric resistance that varies with moisture absorption. This sensing material often is like a film or substrate that changes its resistance as it absorbs or releases water vapor. By measuring this resistance, the sensor can determine the humidity level, and the resistive humidity sensors are known for their simplicity and cost effectiveness. Now let's the image for that is like this. This is the this we have seen in the last slide itself. This is how it looks for the resistive humidity sensor when the uh, these comb-like structures are the films or substrates which absorbs or releases water vapor. By measuring this resistance, the sensor can determine the humidity level. Next, we are going to see about thermal conductivity humidity sensor. Thermal conductivity humidity sensors rely on the fact that air's thermal conductivity, which is influenced by water vapor content. The sensor typically consist of heated sensing element exposed to the air. The heated sensing element is nothing but the thermistor, which we use in industries and for experiments. This the rate at which the heat is dissipated depends upon the thermal conductivity of the air. which changes with the humidity. By measuring the heat dissipation, the sensor can calculate the humidity level. The thermal conductivity sensors are durable and work well in various environments. Now let's draw what the thermal conductivity, the conductivity humidity sensor. Now the as I said, um, the thermal resistive humidity sensor consists of thermistors, and the it consists of dry nitrogen uh, for the for electrolyte as electrolyte. Now let's take a cylinder like structure where we are having these two are thermistors, and here dry nitrogen is being filled. Here there are holes for moisture to enter the this sensor. When the moisture enters into this holes, uh, the the thermal reaction happens like which where because these thermistors are connected to an electric circuit. Like say we can have two resistors and a circuit which gives powers to the two thermistors. When there is a contact between these thermistors, that is the heat change between the thermistors, there will be a change in voltage, and this voltage will be converted into an electrical signal to the monitor, which gives us the actual humidity level of the current temperature. Now let's see about um, in addition of what we are seeing is more humidity sensors in industries, followed by we can say there are other humidity sensors like um, um, optical humidity sensor, gravimetric humidity sensor, then acoustic wave humidity sensor, which is called as that is surface acoustic wave humidity sensor, and we have a radio frequency resonated humidity sensor where sensors will monitor the moisture content in the surrounding air. It's like harvesting. It's like the this the radio frequency antennas will capture the amount of moistures in the air around them, and this frequency is being calculated into humidity levels. In other hand, the variations in resonance frequency of an RF resonator caused by humidity sensor is dielectric in constant. Now let's see about the applications of humidity sensor. Now let's see about the applications in humidity sensor. Like for first we can take about the weather forecasting. Humidity sensors are the integral components of weather stations and meteorological equipment. They help us in gathering the data about atmospheric humidity, which is essential for accurate weather forecasting, which is more useful in these rainy days. Whether these sensors are used to tell us about the upcoming cyclones or tornadoes, which will be which will be sensed with this humidity in air. Then the next application is about in HVAC systems. The heating, ventilation, and air conditioning systems use humidity sensors to regulate the indoor air quality and comfort. These sensors help to optimize the temperature and humidity levels for human comfort and energy efficiency. For example, we say the HVAC, the air conditioning uses the room temperature as air to convert it to the cooling air. It sucks the room temperature air, but after sucking the air, it will filter the air by some filters to reduce the some impurities like dust, sand, or some smoke. After that, it is being filtered the moisture level, because if moisture level enters into the uh, um, what is it? It's called as compressor. When the moisture level enters into the compressor is filled only with oil, where it will compress the air and it will give a it will convert low pressure air into high pressure air. When moisture enters into the aluminum coils and the compressor, it will damage the air conditioning system. So maintaining a perfect humidity level makes the air conditioning work properly, so that humidity sensors are have been projected in have been fitted in air conditioning systems. Next, we can see about industrial process. Industries like pharmaceuticals, foods and beverages, and uh, manufacturing sectors use humidity sensors to control and monitor the quality of products and the processes. Um, they used to control the moisture content in the industry. So because the food beverage companies may have cold storages to store the food products they have prepared in cold storage. So in that cold storage, like we said about HVAC, the humidity level should be maintained as perfect, so that they use humidity sensors in these factories. Main importantly, we can use humidity sensors in agriculture for monitoring and controlling the humidity levels in greenhouse. Um, the maintaining optimal humidity is crucial for growing plants, and these sensors contribute to create a favorable environment. As we are going to nowadays, some of them are doing greenhouses in their home itself, like terrace garden. They can use these humidity sensors to save the plants from heavy rain or too much sunlight. If the humidity level is low, there may be some sprayers which spray water to the plants to keep the plants healthy. Where when there is more when there is more higher moisture level, it the the sensors will detect and say there are more there, then we can reduce the moisture content there, so that the plants will not die. Then in healthcare, humidity sensors are very much important in laboratories, clean rooms, and storage facilities, where they are maintaining specific humidity levels for crucial equipments and performance of the equipments. Um, then these humidity sensors are used in data centers, which requires a precise environmental control to ensure the reliability of electronic equipments. Because if in a like we say like in um, sorry, like we say for example, we are having a mobile phone industry, so we are producing more number of mobile products, integrated chips, microprocessors. These chips should be done in the low moisture level rooms, because if moisture level is higher in the manufacturing area, it may affect the microprocessors uh, in damage or uh, damage. Like next, we can use this sensors for home automation. Nowadays, smart homes are the next level of generation we are using. So we can use these moisture levels controllers for the where the home is fully been centralized with air conditioning. That is centralized AC is been initialized. So we can have a humidity sensor to um, monitor the humidity, moisture level in the air temperature. And we can use IoT devices to tell the you can monitor the humidity levels within your phone using these IoT devices. This is also an advancement in this generation. Now um, some next we can see about the automotive industry. Humidity sensors are used in vehicles to control the climate system. They help to regulate the humidity inside the car, controlling to percentage passengers comfort. Like when we are driving in a rainy season, it may the moist when the moisture level is high, it may block the windshield with water vapor or water droplets. But it may be more disturbing for the driver to drive the vehicle. So that moisture level indicators and heaters are being initialized in now mobile vehicles, which can prevent these moisture contents and etc. Then consumer electronics. The final part is consumer electronics. Some computer electronics like dehumidifiers, air purifiers, and smart home devices incorporate humidity sensors to enhance their functionality. We know about humidification. That is uh, like I'm said, when there is less moisture content, we have to humidify the air by spraying some water or water vapor, something like that. Dehumidification means removing the moisture content from the air atmosphere, like air conditioning is doing. And air purifiers. These air purifiers also include humidity sensors to show the purified air, whether there is for beginning what is the moisture content in the air, then after filtration what is the moisture content in the air. It must show so that they fix humidity sensors in air purifiers also. Now let's see the final slide. Um, this is like a picture. This is like an animation where the humidity sensor works. You can see in this there is a dielectric medium, two electrodes, and down is a silicon wafer. The H2O, that is the water vapor, enters into the dielectric medium, which is like the electrodes. Um, then you can see the graph. The graph is being uh, increased. The relative humidity, the graph represents the capacitance and the relative humidity. We can see the what once the water vapor enters into the sensor, the sensor level increases. That is, there is an voltage difference, and this voltage difference is converted into a signal conditioning, and this signal conditioning is transferred to a display unit to display the amount of humidity level. Now, um, and this is my final slide. So I'm concluding with this topic about the humidity sensor. Thanks for this opportunity to present this presentation. This helps me to increase my presentation skills. Thank you for to my professor, Dr. Sukumaran. As Thank you.